Se agradece. También puede levantar la mano.
I have a question.
Oh, sorry.
Yes.
In the slide 28, you show different time of flowering between two provinces, Gansu and Hubei.
Yeah.
Why is that there's any difference between these two provinces?
Because the Guangzhou province is a short photo period. You can say short short growing season for rapeseed. But and Hubei is a, you can see the long day photo period in Hubei province. So we have compared to the short day season is also, and the long day season is also. So that's why we have compared these two provinces for our mutant plants.
Okay, thanks.
Thank you, Rasme. Any question? Any more question?
Sally?
Carlos, Professor Carlos.
Yes, sir.
Thank you. Thank you for your presentation.
Thank you.
Your review was very complete. And I have a question about the polyploidy of Brassica and Apus. I think it's a allotetraploid species.
Yeah.
What is the main technical problem using CRISPR in polyploid species?
What thing we have observed the CRISPR is also in polyploidy to knock out the in polyploidy species is very difficult. Multiplex gene editing is very difficult by CRISPR-Cas9. So we are just struggling to different crop to optimize the protocol and the transform. First of all, the different species have a very different screening of the transformation method. So some first to screen the cultivar for which is best for the transformation by CRISPR-Cas9. This is the main difficulty in species because some polyploidy species is not screening until for CRISPR. This cultivar will be helpful for creating the transgenic mutant plant. This is the one thing, and the other thing is that some crop is very complex in flowering mechanism, like to develop the. So this is the another, and also one thing in polyploidy is different of target. Also, in if we knock out the specific target, then we have observed different type of phenotypes. Like we have also observed different type of phenotype in like we have observed the sleek length is like the chili. So and the some sleek is will be like 6 pod shattering and different type of mutation we have. There some is the mutant plant and the height is very high, but the some is mutant plant the height is very low. So this is a different mechanism. So we are struggling to specify these targeting by CRISPR-Cas9 in polyploidy species. I think this is a very major problem in this.
Thank you.
Ready?
Sí, Simon. Professor Simon.
Sami,
yes, sir.
What are the effects of mutant in seed production?
Mutant in seed production, like the seed production will be normal. We have that there is a no effect by CRISPR-Cas9 after we get the tDNA-free homozygous mutant plant. The seed production will be normal. But when in T0 and T2 generation or T1 generation, you can see the homos is a transgenic plant. So you can say if the transgenic plant, if the plant have something, then you can see actually disturbed. But when we have get the homozygous tDNA free element, there will be no effect of seed production. The seed production will be normal, and we have also checked the seed weight with the wild type. It will be normal. There is no effect on seed production.
Is also early too?
Yeah, the harvesting plant is almost 19 days. We have harvested within the 90 days. So this is our objective. then we have this after 90 days, we have growth again in the growth chamber to get another generation. So this now we have the DNA free homozygous plant. Now we will multiply in commercially like as a short duration crop.
Okay, thank you.
Thank you, Simon. Professor Simon. Sunny, in the chat, Professor Claudio has a question. Maybe you can see, or I can read.
I can read it. Oh yes, I can.
Okay, okay, Claudio.
Sunny, please, can you? Well, you said that the high tom method was discovered.
Yeah.
But my question is, do you think that any methods is discovered or methods are developed?
Covered or developed? Sorry, I can't understand.
Methods like high tom are discovered or are developed?
No, it's discovered. You can see by Liu et al. It was discovered in 2019. Is already optimized.
Yes, but could you say that methods, any methods in science, are developed or are discovered? Because you can discover a new plant, for example. You can discover a new pathway. You can discover a new gene. But could you discover a method?
Yeah, this is a new method, discovered new method, like to screening the CRISPR-Cas9. Because in CRISPR-Cas9, if you will do the NGS and you can see the direct sequencing, then the result will be back. But you will only choose on the probability that this plant will be maybe homozygous according to the I have explained according to the page result. So you can have only probability. But from this method, after this method, mostly labs using this method in China. So according to this method, you have no probability. You have sure about the percentage. This plant is 91% wild type, then you will not choose this plant because this plant in the next generation will be wild type. So you can choose only this percent. So this is a very reliable method for screening in CRISPR.
Yes, I understood what the method does, but my question is before, or it really doesn't matter what the method does. Well, my question is going, I intend to address something that is previous to anything about the methods. It's about the concept that you have about discovering and developing in science.
No, we have used just a method. We are not developing and discovering. We have used just method to optimize the mutation screening in rapeseed.
Okay, you are using a method. That's fine. That's fine. You are using the methods, but I am asking the people that develop that method. Do you think they discover the methods?
Yeah, they discover the method.
So what is the difference between discovering something and developing something? Or do you think there is no difference?
The developing something, I can say, because the previous method is not reliable. So they think this method is also, you can see by the shell. So they are just, I think it's developing. We can say that if they are in under process, but they have optimized all these things. So they have discovered.
Okay, that's fine. That's developing. That's developing. And discovering?
Discovering, they have already optimized all the things. Then there is no change will be in future according to this method. This is discovery.
Sorry, I didn't understand. Please can you say it again?
Yeah, I mean, this method is already discovered. There will be no any change in future because this is all you can see, tell the whole story, optimize for CRISPR according to mutation screening, everything. I think this is discovery because there will be no change, didn't change in this method. So this is the protocol. So I think this is discovery. This is the difference between developing and discovery. Developing maybe in future much be better. But the discovery, this is the reliable method, is whole story, tell the whole story about this thing.
Okay. For me, is what your definition of discovering it's part of the developing. Discovering is when you find something that is new in nature, in a phenomena that appears to our eyes, and then you try to understand it. But that's okay. I wanted to know what was your definition, because for me it was confusing. But I see that. Well, I think that what he's discovering is not what you're saying. But maybe it's just a matter of opinion. Okay, thank you.
Thank you. Thank you.
Okay, thank you, Claudio. More questions or comments? Maybe in the... No. ¿Hay más preguntas? ¿Pueden levantar la mano? No. Si no hay, podemos finalizar.
I have one question.
Okay, Claudio.
Thank you. It's about the last, I think it was the last slide. Yes, because for me it was confusing in that maybe I don't know exactly the reproductive cycle of this plant, but reproductive phase shouldn't be after the vegetative phase.
Yeah, this the vegetative phase. I have also this method developed by the Lee Hickey from Australia, but I have also 2 review article on this speed breeding. So when actually this method we need to extend the photo period by like 22 hour we need to give the light, and 2 hours for the dark period. So the whole, it doesn't matter, it will be reproductive phase and vegetative phase. This is, you can see the whole period is growing fast than the normal condition.
Yes, but the reproductive phase is when the plant is flowering.
Yeah.
Okay. Because in your slide, it was...
No, the vegetative phase when the plant is flowering.
The vegetative when the plant is flowering.
Yeah.
Okay. Thank you.
Great. More question? The last chance. Sunny, can you stop sharing, please?
Okay.
Okay, we end the round of the question and finish the seminar. Okay, your seminar, Sunny. On behalf of the doctoral program, we appreciate the participation, your participation, and the attendance to this interesting seminar, Sunny.
Thank you.
Thank you very much, Sunny, and take care in China. And we hope to see you soon, okay?
Okay, thank you. I also hope to see you soon.
Thank you.
Thank you.
Thank you,
Sunny.
Sunny. See you.
We're finished.
See you.
Terminamos entonces, chicos. Muchas gracias a todos. Voy a detener la grabación, así que gracias, Sunny. Gracias a todos ahí. Oye, van a sacar una foto, así que los que puedan colocar la cámara. Carlos Figueroa va a sacar una foto. Take a picture, Sunny, in this moment. Carlos Figueroa, profesor Carlos.
Okay.
Bueno, los que somos ahí, los que aparecemos, ahí está apareciendo. Le damos unos segundos, ojalá. Eso, ahí, bien, excelente. Ahí está Fernando. Hello, Fernando. Fernando.
Hola.
Estamos listos entonces. Muchas gracias a todos por su participación.
Gracias.